previously we saw how we could take two different variables and we can see how they're related to each other by creating a scatter plot. And we saw many times that the data appear to be linearly correlated. The data falls roughly in a straight line. What we would like to do in this section is figure out how to construct the line that best fits that data, best explains that relationship, best approximates that relationship. Okay, we call this line the line of best fit. Or the least squares regression line. And we call this process of finding this line linear regression. Least squares here references the theory behind how we find this line. Okay, that's where that phrase least squares comes from. Now, we are going to let R do the heavy lifting here. So suppose we have two data sets. We have a list of data X and a list of data Y. Then using R, we can find the coefficients of that best fit line of the line that best fits the data through the XY points by just typing LM Y tilde X. Okay, so here X needs to be a list of values. And Y needs to be also a list of values, and these two lists need to be paired. Okay, so they should be the same length because every value in the X list needs to be paired with the corresponding value in the Y list. So the first value in X needs to go with the first value in Y. The second value in X needs to go with the second value in Y, and so on. Okay? Y tilde X, this means that we are assuming the data in Y depends on data in X. Okay? It's just a way to tell the calculator which is the independent variable and which is the dependent variable. Okay? And then LM here, the reason we use LM is we are constructing a linear model for the data. Okay? That's where that LM comes in. All right? So let's take a look at an example. So I have here some data values, and I'm going to get my calculator going here so I could use my calculator to find the best fit line through these data values. Okay, so I have two lists of data. I have X and Y. Notice that the X and Y go together, so I have some points that go together. I have the point 5, 6, 2, 4, 4, 2, and so on. Okay, so I want to make sure that I keep the order the same. So I'm going to create my list of data values in X first. So I have 5, 2, 4, 5, 11, 0, 8, and 5. Okay? And then the list of data values for my Y variable are 6, 4, 2, 7, 13, -2, 12, and 8. Okay? And now I want to find the line that best fits this data. And perhaps it'd be helpful to first see what this data looks like if we plot it in a scatter plot. So let's create a scatter plot very quickly. Okay, and we see we have a scatter plot here. Okay, and we could see that roughly the data do appear to fall in the line. It's not exact, but we have that rough pattern, that rough relationship that we are noticing. Okay, so we want to find the line that best fits the data. So we are going to ask to to construct a linear model. Let me get rid of the scatter plot for now. Linear model, and I want y to be dependent on x. Okay? So see what it gives us. It gives us two values. It gives us the y-coordinate of the y-intercept. This is our a value in our linear model. And it gives us the coefficient in front of x. This is our b model. So our best fit line we know it should look like y equals a plus bx. That's what lines look like. That first value is our a, so that's negative 0.625. And the next value is our b, 1.375. So this is our best fit line. This is the line that best explains the pattern or relationship we're seeing. Okay? Now it's going to be helpful if we could see the scatter plot together with that best fit line. That'd be just a little bit helpful to see what that line is actually doing. Okay? So to do that, we're going to start by graphing the scatter plot. We do that the usual way. We've already seen this, right? We use the plot function. We say plot the xy points using the x values in variable x and the y values in variable y. Okay, so we get the scatter plot we're used to. Okay? And now to add that best fit line to that scatter plot, I'm going to use the function AB line. Okay? And I tell it what the A value of my line is, in this case negative 0.625, and I tell it what the B value of my line is, the slope, 1.375 in this case, right? So generally you can graph the line using the function AB line, plugging in your A and your B values. And I should note that you need to do this after you plot the scatter plot. It needs a graph to already be there for this to work. So you graph the scatter plot first, then you can call the AB line function to put the line in the scatter plot. Okay, so let's see what that looks like. Okay, you can see we have our scatter plot, and in that scatter plot we have that best fit line. Okay, this is the line that best fits or best explains the relationship we are seeing. This is the line that best fits the trend in the data. Okay. Now, looking under the hood a little bit, we don't need to know this because we're going to let the computer do the hard work. But just so you know what's going on, what this best line is doing is it's checking the squared distance of each point from the y values. Okay. So looking how far each point is away from the line. This one would be up here somewhere. Okay? And it's choosing the line that makes that the square distance between the point and the line. It chooses the line that makes the total distance, if you look at all those distances, smallest. It minimizes the distance. Okay? And that's why sometimes we call this the least squares regression line, because we are finding the least different distance, or the least, we are minimizing the squared distance between the points and the lines. We're finding the least squared distance. Okay? And so that's kind of what's going on under the hood. Again, we don't really need to know that. We're going to let the computer do the hard work. LM y tilde x, that's going to do all that work for us and going to give us that best fit line. So we can use that best fit line to tell a story about the trend in the data.